Hello folks, this is the video tutorial for chapter 8 of my textbook. The title of the chapter is Impulse Loading on a Simply Supported Composite Plate, and the book is of course Composite Finite Analysis Essentials for 3D Experience. Now, the problem that we're going to look at is a plate, square plate like so, simply supported on all four edges. As you can see, this is the condition that we want. And it is subject to a loading. Now, of course, it is made of a cross-ply uh, uh, laminate, two layers, 0 and 90, thicknesses of 25 millimeter each. And the dimensions of the plates are given here. The plate is given here. Now, of course, this thickness is relatively large. It's quite large compared to this length. Therefore, it's only for exercise purposes, show you how to do it. Generally speaking, you don't have laminates of this thickness, okay? But this is, as I said, only for the demonstration purposes. In real life, these thicknesses are a lot smaller than this. Now, the material properties are given here, and this problem is taken out of the classical book of Ready down here. And what we're going to do is we model this thing with a very coarse mesh. So basically only four elements, quadratic, parabolic each. And the only reason I do it like this is that I want to be able to compare it with some available literature, which was done with this kind of a mesh, okay? Now the load applied is a pressure load of 100,000 Pascal. Now, what that means is that this pressure is suddenly or impulsively, that's what impulsive means, suddenly applied to that to that face. Now, if it was applied slowly, it would be a static problem, and that's chapter 7, okay? But this is applied impulsively, so it's automatically become a dynamic problem, and we're gonna solve it. And we later on at the end, I'm going to compare the results with what is obtained from Abacus, same problem, Abacus R19, and CATIA V5 released 2018. Now, the only thing is that this CATIA one, I believe I took 30 modes, whereas here in this exercise, we're going to take 10 modes. Okay, so let's go ahead and create our model. There we are. So let's do this on a horizontal plane, XY plane. We're going to draw a rectangle of dimension. Let me make it centered, although it really doesn't matter. We're going to make it centered like this, okay, of dimension 250 by 250 millimeter. So this is 250, and this one is also 250. Okay, exit. And go to the surface right there, surface, or you can use the you can use a bound fill here. Okay, if you can't find this thing, go to surface and you're going to find this fill there. Okay, so right there. Okay, and we say okay. All right, now we're going to create an axis system which eventually is going to be used as our rosette. So let me go ahead and do that. uh, Essentials, axis system. Now, ordinarily it puts it at the global origin 000, which is right there, and it's aligned with the global axis system. Now, if you don't want this thing to be placed here, you want it somewhere else, you can always specify the origin of it. So if you put the cursor there, right click, create a point, and for the Y, I give it, for example, 300. What it does, it creates a point. Okay, it creates a point here, and it places it there. Actually, I didn't want this thing. I wanted X to be consistent with how it's done in the book. I wanted X to be uh, away, 300 millimeters away. So there it is, 300. So it's going to put my coordinate system here. We say fine. I always uncheck the current, and there we are. And let me see, why did it not move? The Default origin is here. Let me do this thing again. Let me delete this. Okay, try it again. Access system. Already created a point there, so right there, place it in that position. Okay, very good. Now we're going to save this. The next task is for me to create my material properties. So I go and well, I go back where I was, mine here, under tools, under material browser, and create material. I'll call this thing video chapter 8, impulse. It's really not an impulse, it's impulsive loading. So we say okay. It's going to create for me a material with that name, and I have two choices. I can specify my properties right here before applying, or I can apply and then define the values. So let's see. Yeah, I'll define it right here. In fact, in the book, I said I've done this thing so many times that I leave it to you to decide how you're going to use how you're going to define the material properties. What did happen here? Service encounter error. Okay, so that's fine. Let me close this. Let's try it again. Already, I'm not even sure if this created it, but let's try it again. Video, chapter 8. What was it? Impulsive. Okay. We say okay. All right, right there. Now, the only reason that it doesn't appear here, you can see that it doesn't appear here. That's because I didn't save it. So let me close this. Let me close this. Okay. Save my model. All right. And now I go to my browser, and this should be appearing there in the list. Right here. See that? Right click, composite. Now the thickness, cute thickness is 25 millimeter. I said that this is unrealistic, but we're going to be using it because I want to compare our results with that of other sources. Right click, simulation. So this is going to be uh, Abacus Multiphysics. Now we do need the density here because we're solving this thing as a dynamic problem. We definitely need the density. So I'm going to put 800 here. That's what it was in my table. And then we're going to go to mechanical, elasticity, elastic, and lamina. Type is lamina, and I put all those numbers that you saw in the table. So that's going to be 525 gigapascal. E2, which is transverse modulus, is 21. Poisson ratio is 0.25. The shear moduli, 10.5 in this plane. 10.5, oops, wait a minute. 10.5. Same thing in the other plane, 10.5. And down here in this plane, it is 4.2. Okay, I believe you're okay. That's all we need. We say all right. We're gonna save. Well, it's already there. That's already saved. Let's save it actually. Now we're gonna apply. So right click, apply. You have to get this thing out of the way. So I'm gonna either make it smaller or close it, whichever you want, and apply it there. Green check marks and close it. Okay. So notice that your material with that data is over here. Now I want to have access to this, and I don't want to go and search in the database. So one way of doing this is you go to the robot and say material definition, and notice that this is the first one that I did, and I lost it. Okay, something went wrong with the system, and this is the second one that I did. That's the one that's at my disposal now. This first one I created it, but somehow I got an error message because of probably internet communication. But this one is already done. In fact, we can check it. This is the one that I inputted the number. Okay, you want to check it? Double click on it. You see, there's your 25 millimeter. Very good. So this is going to be at our disposal. You can seamlessly go between the part and the material in session, material in session. Okay, so let's save everything. And now we move on to the rest of the problem. So we have to go to the composite design workbench. Okay, so we're going to go to the composite design workbench. Let's go. Now, let me remind you that if you don't want to get confused, make sure that you're at the 3D shape level when you do that, okay? So you go to composite design workbench. There we are. And we're going to do this thing with apply design. There's only two applies, so we're going to do that manually. First of all, composite parameters, add the material in the library. Now this is right at my fingertip, right there, this tab, material definition editor. You just go and select it, and this is the one that I wanted, right? Video chapter 8 impulsive. And when I do that, it takes the information and populate this table. There's your 25 millimeter cure thickness. Rosette, add a rosette. We created it one right there. And that's it. So there's nothing else for in this, at least in this stage. So save everything. And now we're going to create our plies group. So there's a surface. Draping direction is up. We're going to keep it like that. And then we create our plies, ply number 1. Notice that nothing happened. It's waiting for you. If you read the bottom left corner of the screen, it says select ply group or sequence or ply to create a ply. Okay, so here it is. I create this ply group. It's expecting me to select this, and there we are. For the boundary, we select the sketch. It's very simple. And for the attribute, the first ply is 0 degrees. All right, let's do another one. There's ply number 1 is created. See that? Ply number 1. Another one, same group. Boundary is the same. Attributes, the only thing is that the angle is 90 degrees. Okay, that's it. So why don't we save everything and let's check our work. And the way I check my work, I use the ply exploder to have the plies on my or the layout on my screen. So you go to the review tab right there. See the review tab, and there is a ply exploder, ply group 1, apply, and there we are. This bottom one is the reference surface. This is 0 degrees, and this is 90 degrees. Cancel. I don't need that. All right. So the next thing is the meshing process. So you go to structure model creation, defaults, keep the defaults. Okay. Let's mesh it first. So we go here. You go to this menu. Go to mesh. We're going to use a surface quad mesher right there. You select the surface. It's parabolic, quadratic, and the size. Remember, this whole thing was 250 millimeters, so I take half of that, something to that effect, and then it's going to put it's going to put 2 elements this way, 2 elements that way, and that's pretty much it. Nothing else. And there is my mesh, and we say okay. Okay, so my mesh is created. All right, so you can see that there's 4 elements here. All right, now we're going to do our sections. So to do the sections, you have to go to the model right there. From mesh, you go to model, and then you go to composite shell section. The support is that fill basically, okay. And for the composites, for this item, you go to the pull down menu and say plies. And it says, okay, you have created one plies group 1. Is this what you want? The answer is yes. Double click on it, and it's going to put it right there. The other thing that you're going to do, you expand the advanced option, And this is where the offset is defined. We don't want any offset. What that means is that this surface that you see there is the middle surface, okay? This is the middle surface. Half of the composite is below it, the other half is above it. And because of the fact that they both have the same layer means 25 millimeter above it, that's 90 degrees, and 25 millimeter below it, and that's 0 degrees. So we say none, basically. That's all I'm saying. We say okay, and save everything. So we have created our nodes and elements, obviously, and we have created the properties, the composite properties section. That does it. So now we're going to switch to the structure of scenario creation. Okay, it's a structural problem, so we're going to leave it as default. Okay, so we say okay. Notice that immediately you get the two exclamation marks here, means these are not defined, and we have to do that. So we're going to go to setup, finite element model. This is the only one that we've got. We created, we selected, we say okay. Immediately this becomes a green check mark. Okay, and then we're going to go and create our procedures. Procedure means the first step is extracting natural frequencies, because I'm going to solving this problem using the linear dynamics approach, which CATIA calls it, not CATIA, sorry, 3DEXPERIENCE calls it modal dynamics. So in order to do modal dynamics, you need to have first the frequencies, extract the frequencies. So the first step is going to be frequency step. Okay, this is the first step. You click on it, 10 frequencies, 10 modes are going to be extracted. If you want more, you just put it in there and read the book about the significance of this number of modes that are taken. This is important, but not in the present problem. We keep it as 10, okay? You say okay, and notice that the step has been created and it's called frequency step right there, okay? Now, for the frequency step, all we need to know is what the restraints are. There are no loads in a frequency step. So you go to restraints, fixed displacements. Now this edge and that edge, okay, if you go back to the slides that I had for you, these two edges, okay, vertical displacement is always 0 because this is simply supported, but these two, so on two of them u is 0, and two of them v is 0. So let's see now which two of these things do not move in the direction x, so x is fixed, of course z is fixed, okay, these two do not move in direction x, okay, and do it again on the other two edges. This guy and that guy don't move obviously in the direction z, and their y is fixed. Okay, that's good. So we say okay. Now I can solve the problem right now, and I get the 10 frequencies, and I can use it later on. However, I can define my second step and run them simultaneously, okay? And in the book, that's what I've done, and I'm going to stick to it, okay? Now, before I do that, let me remind you that we need the 10 frequency, we're going to extract it. But then we need in the second step, once we do the transient dynamics, we want to plot the vertical displacement of these two nodes, the one in the middle, because I want to compare it with what I have, and another one. So you really need to create a group. So let me go and create my group, manual group, okay? So here's what I mean by that. First of all, let me clean this up, okay? So right click, mesh visualization management. Don't show me the part. Don't show me the part. It cleans it up a little bit. You just leave it there. So I'm going to go to the model. And when you go to the model, you have this thing called group right there. Group. Okay. And I'm going to do the manual group. Manual group means I'm going to pick the nodes. So first of all, these are blocking my view. Let me once again hide the part. There we are. Okay. So I'm going to say manual group. It says, okay, go pick it. Now, for me, it's easy to go and pick them one by one, okay? But sometimes you may have, you want to select a collection of them, and of course, you're going to use the different way of selecting these things, okay? But right now, I'm going to say, this is the first one right there. See, one node is selected in this group, and then another one is going to go here, two node is selected. Okay, so this is very important because in order to plot the displacement, transfer displacement, you're gonna have to use this manual group later on. Okay, so let's proceed. Where were we here? We go back to scenario, and now we're gonna go to our procedure, second step. Okay, we already created one step, which was extraction of frequencies, and then we're gonna go to this last one, modal dynamics step. Okay, now this means total duration of time that we are interested. And I'm going to put 0.0004 seconds, okay? Because if you look at the stuff that I have here, my total duration time, my total simulation duration is 0.0004. Okay, and this second one is how many steps do you want? If I want 100 steps during that time interval, I put two more zeros, another make this 10 to minus 6. So we're going to go 0.123124. Okay, you can see that. All right. Now, do you want to use all the modes or some of the modes? We're going to use all the modes. That's fine. We say okay. All right, so we created our second step. We can see that, which is modal dynamics. Now here is where you need to specify the load. Okay, so we go to load. We select that pressure on that face, and I put minus 1.12345 Pascal. Okay, Newton per meter Pascal. All right, and yeah, that's pretty much it. So we say okay. Okay. And I believe that we have done everything that we want. So there's only one thing that needs to be done, and that is ask for additional information because we're going to need it for plotting purposes. Okay, so let's go ahead. Let me, by the way, let me check the sense of my pressure. Yep, this is transverse, right? Okay. Yep. All right. The figure in the book may be a little bit different because the arrows may be up there, but this is not a major issue. So okay, so all right. So we go to simulate. We're gonna go to output, output. Okay. Now we don't want the whole model. We want a group. We want a group. We want to. First of all, let's do it like this. Yeah, for group. It says you have only one group, the manual group. We select it. And we don't want field, we want time, history, time and frequency means history plot, and we want a displacement, and we want a translations. That's all. We don't want any of these other things, okay? And that's pretty much it, unless I forgot something, which I don't think I have. So we say okay. All right. Before we run it, we're going to save this. Okay. So it is a good idea to go and do all these pre-checks. So model and scenario check. Let's see, something is wrong here, and I know exactly what happened. Now, I've said that repeatedly in the previous videos, and I have it in the book. What I'm saying is that remember those restraints that I applied? Remember those? I selected these. Unfortunately, I did not hide my sketch. I did not hide my uh, plies. So that's why I probably put it on something that is not a geometric entity. Okay. So here's the best thing to do is go here. Let me let me delete this. you don't have to delete it. Let's do it like this. First of all, before we do that, we go to our part, hide the sketch right there. Hide the sketch. This is repeatedly mentioned in the other videos and in the present, in the book, okay? And hide the stacking engineering. And hide the composite parameter. I don't think this is important, but we're going to do that. Okay, now let's go back here and double click on the first one. Okay, and on here I say remove all. So these two were something is still blocking my view. So let's see what else it could be. Um okay. Oh, I have a feeling that I did. Let me see now. Show my part. The part is showing. Yep, yep. Hide the mesh. Okay, let's try it now. Double click on the fix displacement. Remove the two edges. And now I'm going to select these two. This point, this edge, and this edge. Remember, these do not move in the X direction. Okay, that's good. And double click on this. Remove these two edges. They were not really two edges. They were things that were not legitimate. And by hiding that, I can access the correct one. Remove, and these two, 1 and 2, and we say okay. Okay. And I'm glad this happened to us because you can see that there's a reason that in the book I say hide this, uh, and okay, let's try it now. Yes, this time it did run, it did check, simulation check. Okay, so this is fine. Give it time. No error message, but there is a warning message here. I'm not that concerned about warning messages unless things go nuts. We haven't even run it yet. This is just your checks. And then finally simulate. Incidentally, down here, because you have two step, you have the ability of select them. Okay, but I didn't do that, so it's going to do both steps. Okay, but if you did not want to run the frequency, you make a change. For example, change the load. You don't want to run. You don't want to change the load. You don't want to run the frequency because they have been already extracted. Then you can switch this thing to model dynamics and then run it. Okay. I think it finished, so let's check a few things. Okay, so close that. Okay. First of all, let's go to the frequency step. 10 frequencies calculated. Okay. I just realized that these are not the same frequencies that I have in the book, and I believe part of the reason was that I had the wrong restraints here. Okay, so let me check. Let me show you a few things. First of all, you can look at the frequencies. There is no problem here, but these numbers are not the same ones that I have in the book, and it has to do with that restraint that I put. So let's go and fix it. Let's go and check it actually. So I go to the fixed displacement here. See what I did. Okay, so let's see. These two edges do not move in the direction Y. Bad mistake. not X, Y. These two edges do not move in the direction Y, okay? And the other one, these two edges do not move in the direction X. So these are completely reversed, okay? Now we're gonna run it, and I'm not gonna run, I'm not gonna check because I'm pretty sure everything is gonna be okay. Yep, let's give it time. Okay, these in this video I ran into some glitches, and that's good because you get to see what possible problems may be, and we fixed them both. But you know, things are not always as smooth as you see in the video tutorials on YouTube. Okay, things can go wrong. Either you have to redo the whole video or work with you on the screen trying to resolve the issue, and that's what I've done. Remember, the one that I ran before, the first frequency was 5,000. Okay, I think now it's going to go drop down to 4,000. I knew these numbers. Okay, so that's fine. So these are the different modes. These are the vibration modes. Okay, now if you want to see the mesh here, okay, which is a very coarse mesh, of course, you click on the contour plot and you go to this last tab. See this last tab, and you say, don't give me the outline, also give me the mesh. Okay, so here's my mesh. Okay, very good. Now, uh, we then want to go and plot. We want to plot our displacements. So, as a function of time. So you have to change, obviously, from frequency step to modal dynamics step. Okay. And the question is, how do we plot this? How do we plot as a function of time? Now, first of all, one thing I can do is down here, you see this down here? XY plot from history. You click on it. Move this thing here. All right. So first of all, I don't want frequency step. What I do want is, well, let me actually do this. I don't want the frequency, eigenfrequencies. I want the translations right there. You see that? Translations right there. See this? Okay. Now I don't want the magnitude. I want the component in the direction Z. Okay? Because when it's positive, I want to show it as positive. When it's negative, I want to show it as negative. I don't want the magnitude of it. And I want, notice that as soon as I did that, by the way, this thing changed from modal dynamics, from modal to modal dynamics. Okay, good. Now I select this thing. Well, actually, let's say apply. There we are. Okay. Now that looks different. That looks different from this plot. And you might say, well, why does it look different? That's because my pressure was, I wanted it to be upward. See that? Initially, I wanted to be upward. If you look at this, if you look at this slide, you see that initially, I want it to be upward. So that means I have to, let me close this. Okay. Let's go back to this load. This load. Let me close this thing. Close that. Go to the load. Okay. Remove that minus. Notice that now it's going to go like that, consistent with the slide. So we're going to run it one more time. Now this is where I did not have to do I did not have to do the modal calculation because the frequencies don't change by changing the pressure. So say okay. No errors. All it does is that it flips the thing up. Okay. Very good. So let me close that. Okay. Let me close this. We go to history plot right there. So we select the translation. A magnitude, no, I don't want magnitude. I want vector component in direction 3. And I say apply. It's the same plot that I got before, except that it's flipped up because I wanted to compare it with these things from Abacus and Katia, okay? And to do that, of course, my pressure had to be initially upward. Okay. Now, if you want, actually, these numbers, see that this number is very close to what we had in the other case. Okay, in here, I'm not going to worry about that, but it's consistent. Now, if you just want to see the note 17, because this is note 17 and okay, 21. If you just want to see note 17, then what you can do, you can dot, you can click on these three dots. It says, oh, you know, this group that you picked had note 17 and 21. Note 17 is in the middle, I'm sure. So I'm going to uncheck that, and then I say okay, and then I say apply. Okay, so that gives me the uh, the uh, vertical displacement. Okay. All right. So good luck, and you're on your own now.